May 10th. I am out of school today, but you do have some work to do, okay? So this video is just meant to give an introduction to the work that we are doing today and make sure that you have some review for how to calculate slope. So this is our schedule. Our next quiz is going to be a week from Friday. So Friday the 21st is our next quiz. The constant velocity lab that we started last Friday, that lab report is due this Friday. Also, if you have not already turned in your pendulum lab report, that was due today at the beginning of class. So right now we're going to review how to calculate slope in PowerPoint. After we get through this, there is an assignment on Classroom for you to practice calculating slope. Then you will complete pages 8 and 9, constant velocity, quantitative position versus time graph, part 2. Then if you have not already finished taking your lab data, you're going to want to make sure that you have finished doing that by the time class starts tomorrow. So as we are looking at any position time graph, we've been talking about how the slope is equal to the velocity. And we've been saying the steeper the slope, the bigger the velocity. But now we want to actually do a calculation of how we are going to figure out what the exact quantitative velocity is for each of these segments. So how do we calculate velocity? If we're looking at from A to B, you'll notice we have a slope of 0. So our rise is 0. Our run is 5. So our rise 0, our run is 5. 0 divided by 5 is going to be 0 meters per second. Okay, and for all lines that are a flat line on a position time graph like this, flat just meaning no slope, you are always going to have a 0 meter per second slope. From B to C, though, it is a little bit different, right? Because we have a slope, so we need to calculate that slope. So from B to C, we rise from -5 to -2. So we actually have a rise of +3 meters. We have a run from 5 to 11. So that's a run of 6 seconds. So our rise over run is 3 divided by 6, and we get 0.5 meters per second. So I want us to, you can pause the video for a second here, try to calculate the velocity at each one of the rest of these intervals. So from C to D, D to E, E to F, and F to G. Okay, so let's go ahead and double check our answers. From C to D, again, we have a 0 slope, so our velocity is 0 meters per second. It's easy to calculate. From D to E, we go from -2 to +8, which is a rise of 10. Our run is from 20 to 30, so that's a run of 10. So 10 divided by 10 is +1 meters per second. From E to F, again, we have 0 slope, so our velocity is 0 meters per second. From F to G, we have a rise of 8 to 0, so that's a -8 rise. And then our run is from 40 to 44, so that's 4. So -8 divided by +4, we are going to get -2 meters per second. Why is F to G negative? It's negative because our rise is -8 meters. Okay? So when we solve that out, we end up with a -2 meters per second. Anytime you have a negative slope, your rise value will always be negative. And what does negative velocity mean? It just means that we are moving backward. We are returning to the origin. Okay, so for the rest of class today, there is an assignment on Classroom where you are going to be practicing calculating slope. Okay, so you'll open that and do that in Kami. Then you are going to complete packet page 8 through 9, constant velocity, quantitative position versus time graphs, part 2. You are doing a lot of slope practice within this, okay? There is also a video of me completing this entire pages 8 and 9 available to you if you have any questions or if you just kind of want to work along with that video. And then, of course, finish taking lab data.